The principle of parallax in section 2.3.1 is used for the determination of distance of very distant stars. The baseline AB is the line joining the Earth's two locations 6 months apart in its orbit around the Sun. That is, the baseline is about the diameter of the Earth's orbit, which is 3 into 10 to the power 11 meters. However, even the nearest star is so distant that with such long baseline they show parallax only of the order 1 second of arc or so. A parsec is the convenient unit of length on the astronomical scale. It is the distance of an object which will show a parallax of 1 second of arc from opposite ends of baseline, equal to the distance from the Earth to the Sun. So how much is the parsec in terms of meters? So let's solve this. As we know, the diameter of Earth's orbit is 3 into 10 to the power 11 meters. So the radius would be half of it, that is 1.5 into 10 to the power 11 meters. Let the distance parallax angle be 4.847 into 10 to the power minus 6 rad, and the distance between Earth and star be r. Parsec is the distance at which average radius of Earth's orbit subtends an angle of 1 second of arc. As we have theta is small r by capital R, analogous to the circle, r here is the radius, small r is the arc length, and theta is the angle covered. Therefore, capital R is equal to small r by theta. Putting the values, we get as 0.309 into 10 to the power 17, or we can say it as 3.03 into 10 to the power 16 meters is the parsec.